Hello friends, welcome to my channel again. Today we'll be discussing a problem in topology, and for previous problems you can visit the following link, which the description is given in the link is provided in the description. Okay, so this problem is although from topology, but it is given in the topology for confusion. So this was asked in CSIR NET. So let's see the problem first. So let X be a topological space and A be any subset of X, non-empty. For XY is in A, define X related to Y. So this is a relation. If and only if there is a connected subset C of A such that XY is in C. Okay. And for X belongs to A, define CX, which is set of all Y in A such that Y is related to X. Then we have to see which of the following is true. Okay. Yeah. So as I am telling, although this is a problem from topology, but we will not use any fact from topology. This is just purely set theoretic problem. Okay. So this is a problem of the properties of the equivalence relation. So first of all, we need to see why this relation is an equivalence relation. Once we have shown that this is an equivalence relation, then we can use the properties of the equivalence classes because this is an equivalence class. This is an equivalence class. So once we know this is an equivalence relation, we can use the properties of the equivalence class to determine which of the options are correct. Okay. So I recommend you to pause here and try for the solution or try to show that the relation is an equivalence relation. Okay. So let's see why the relation is an equivalence relation. So I have written note that CX is an equivalence relation with. So let's see why first of all this is an equivalence relation. So what's saying that X is related to X. This is reflexive. Okay. So this is true because what it says that X and if and only if there is a connected subset C of A such that X, Y is in C. Okay. So I can just take this set as C. Okay. And this set C clearly contains X and hence this is a reflexive. Now, why this is? I have to show this is symmetric. So X is related to Y implies Y is related to X. But X related to Y, this means that there exists a C subset of A such that C contains X as well as Y. Okay, C contains X and Y. But for this also, I can take just C as same because it is not, it won't be changing anything. So, hence, this is a symmetric relation. Okay. And why it is transitive? So, let's see. So, X is related to Y is related to Z. This implies Z is related to X. Okay. So, this I'll be getting C1 connected subset of A. This C2 connected subset of A. So I have, this is my C1 which contains X and Y, and this is my C2 which contains Y and Z. Okay, so Z. So since C1 is this and C2 is connected and the intersection is non-empty, main thing is this intersection. So C1 inter C2 is non-empty. Therefore, C1 intersection C2 is connected. Okay, and you can try to prove that this fact that if C1 connected, C2 connected, and C1 intersection C2 is non-empty, then this is true. That C1 intersection C2 is, sorry, C1 union C2 is, so then C1 union C2 is connected. Okay, so here, therefore, I can just take here C1 union C2 as the subset of A. And this proves that this relation is an equivalence relation. Okay, so once we prove that this relation is an equivalence relation, we just, as I told, we just need to apply properties of the equivalence relation. So we have the following property of the equivalence, and this property is very important, that the, so this is an equivalence class, this is an equivalence class. So if two equivalence classes intersect non-trivially, that means intersection is non-empty, that is true if and only both classes are same. Okay, and but what is this class? This class means X is related to Z, and this class means Y is related to Z. This means that X is related to Y. Okay, so this, so two classes are same if and only these elements are related. Okay, now see the options. So what were the options? The first option was Cx equals to Cy, implies X equals to Y. We don't know yet. Cx equals to Cy implies X is related to Y. That's true. Cx intersection Cy is non-empty, implies X is related to Y. That is also true. And Cx intersection Cy is non-empty, implies Cx equals to Cy. That is also true. So we only have to say Cx equals to Cy implies X equals to Y is true or false. Okay, but that is indeed false. Why? Because see, I can just take my set X to be R. So let's draw the picture. X to be R, and let's take A to be an open interval or closed interval, no problem. I'll take A as this. Okay, this is my A. Now what it says that Cx equals to Cy. So let's take X equals to this and Y is this. So what is this? I can just take C as this. So then clearly X is this, Y is this. Then clearly X is related to Y, means Cx equals to Cy, but X is not equals to Y. So this need not be true. Okay. Therefore, what are the options that is true? A, B, C, D. So these three options are true, A is false. Okay. So just to recall what important properties we have used here. The first property, that A and B are connected subsets, are connected. A intersection B is non-empty, then A union B is also connected. The second property, that equivalence class of X. So this is also we write like equivalence class of X equals to equivalence class of Y if and only if X is related to Y, and that's same as X intersection Y is non-empty. Okay, so these two properties we have used here. Okay, so I hope you learned to solve this problem and you enjoyed. So keep solving problems. Thank you for your time and patience. We'll meet you again tomorrow for the new problem in the differential equation. Goodbye. Take care.